Welcome everyone to our YouTube channel. We're looking at proving of trigonometric identities, and with us we have this one, which is left hand side being in parentheses cosec theta minus cot theta equal to 1 minus cos theta over 1 plus cos theta in parentheses raised to the power of half. So looking at this, the side which we're going to work with is right hand side, sorry. So here we're working with the right hand side, which is open brackets 1 minus cos theta over 1 plus cosine of theta, everything to the power half. So now we understand, say, if we have a base raised to an exponent of half, it's the same as saying that the base in this case, which is 1 minus cos theta over 1 plus cos theta, will be enclosed under the square root, like this. Okay. Now we're going to continue writing it this side where we say square root. So I'm going to demarcate. So I'll say square root of 1 minus cosine of theta over 1 plus cosine of theta. Now for such kind of expressions, we do understand that they are already in their simplest form and they can be simplified further. So the one way we can do it, since they are fractions, we would tend to conjugate. So multiply both numerator and denominator by the conjugate of the denominator, which in this case will be 1. The positive will change to be a minus. Then cosine of theta will be maintained. So we'll divide with the same, like this. Okay, this goes up to there. Now, if we multiply 1 minus cosine of theta times 1 minus cosine of theta, we get 2 of these. So this gives us our square root of 1 minus cosine of theta, all of this squared. Then over, if you look at the denominator, I have 1 and the 1 there, so it will be 1 squared, which is 1 minus cos and cos, I'll get cos squared. So the concept I'm using here is difference of two squares. And now if you recall from identities that, if you have the sum of sine squared and cosine squared, you get 1. And if you make sine squared subject, what you do is you subtract both sides with cos, so you have 1 minus cos squared theta. So this will therefore give us our denominator of sine squared theta. But now let's work out the numerator. Now for the numerator, we tend to use, or rather borrow, some concepts from algebra, which is something like this: a minus b, like this, all squared. So what you simply get here is a squared minus 2ab plus b squared. So in our case, our a is simply 1, our b is simply cosine of theta. So let us see what we get. So this will further give us, I'm demarcating this, so this will give us, go as far as this side, so therefore give us square root of, upon expanding, my 1 is my a, so I'll get 1 squared, which is 1, minus 2, 1 times cos gives us cos theta, then plus cos squared theta. When you expand the numerator, let me say O over. Alright, apologies. There'll be no need of us to even expand, sorry. So instead what we'll do is we'll say square root of 1 minus cos theta all squared over. Now remember we had said 1 minus cos squared is sine squared, so we replace with sine squared theta. What we now do next is we'll individualize the square root. We'll say numerator, which is 1 minus cos theta all squared, to be under its own square root over the denominator, which is sine squared, which I can write as sine theta all squared, to also be under the root like this. Now once this is done, we understand to say this square and the square root will go square and the square root cancels out. This therefore leaves us with 1 minus cosine of theta over sine theta. So what we do next is we'll say that this will be the same as sine. So we'll say the first part of my numerator divided by the denominator like this, then minus the second part, which is cos, also to be divided by the denominator, which is sine theta. So this will still be the same thing. Now 1 over sine gives us cosec, so we'll replace with cosec theta, then minus cos over sine simply gives us cot theta, and we can see to say this part gives us our left hand side. So we can conclude say this has been proven successfully. And with that marks the end of this discussion. See you in the next video.